Okay, start. Last class discussion, we're trying to understand the 7 steps of how we start building our machine learning model and how can we start from the scratch. So that thing we are discussing. And those 7 steps, under those 7 steps, we have discussed the first thing we need to have the problem in hand. So that problem we have to define it clearly. What is your input features and what is the expected outcome that you're expecting from the model to predict. So when we have a problem in hand, we have to find out what are the critical points on which the identification of those features or any object or any pattern is dependent on, and what will be the outcome of that whole problem. That you need to find out. The mathematical model is about to create. So you need to design a strategy to collect the data. For example, if I'm collecting the data from soil in an agricultural background, in an agricultural activity, so the soil content that I'm measuring, I'll be taking from various places. So I'll be using an equipment to measure those things. So when I do that, I'll be recording the data from all the different places that it is. Okay. So when I'm recording, there might be some errors in the readings, or there might be some blank data that is not available in the specific column. Okay, that might happen when we collect the data. Now it is your responsibility to clean that data and prepare that data with accuracy as a property and error-free, and we need to create data which is what you can say eligible to be in that column. If one column is having some data which is of numerical values, so it must not contain other type of data. So the data type also you have to maintain. So that thing once it is ready, then you have to go for analysis of the same data that you have collected. What kind of data that you have collected and what that data looks like. So that visualization you have to do. Once that you do, then you have to go for your feature engineering. That you are trying to understand what are the, I have for example 10 columns. So under that, what are my relationship between multiple columns? Okay, how each column is related to each other. Okay, so that thing we need to find out. So this much we have discussed the last class, right? Yes.
In this context, how accuracy and precision are different?
Accuracy and
Precision.
Accuracy and precision. Accuracy is the property and precision is a measurement. We are talking about two different contexts we are speaking. When I say precision in terms of calculators, precision in terms of calculator is how many decimal points are you putting after the dot, after the decimal point. That will be my precision. Accuracy is the property of that measurement. How accurate that value is. That is the property of the measurement. So here, if you talk about, it will be Evaluation, when you do evaluation of the model, how accurate the model is, that means you are measuring its performance. Okay. So that's how it goes with respect to evaluation. Okay, so let's go ahead. So first step we have seen is, okay, we have seen this pipelining. We have told how this pipelining will be done till prediction, and we discussed about data collection and integration, and exploratory data analysis. Exploratory data analysis, where we are trying to create plots, and we're also trying to see how data could be visualized and see how they have a relationship between each other in the data set. Feature selection and engineering. It means selecting what features the developer wants to use within the model. That you need to select among the whole data set that you have majorly, and then we need to look for how model training would be done. All right. I hope you have understood till the feature selection and engineering. Okay. Okay. So model training, as we were discussing earlier, you need to create a mathematical model, or you need to decide what kind of algorithm you need to use for the problem that you have defined. Okay. If you have only two parameters and you want to differentiate, you can go for linear algorithms. And if you have multiple parameters which are varying in space, then you can go for multiple, or you can say classification algorithms. Or if you have some problem or some data which is of visual in nature, like photos are there, or audios are there, or videos are there. So for such thing, you have different algorithms to select. All right. So based on the data and the features that you have selected in the feature selection and engineering. All right. So based on those y values, x values, you are going to decide what model you want, so that I can predict my y value accurately. All right. After the first three steps that we have done are done completely, we enter into the model training phase. We say it is officially when the developer gets into the training model on the basis of data. As we said earlier, to train the model, data is split into three parts: training data, validation data, and testing. Types of division. That is our training data and testing data. Okay. It is validation data is just to validate it before testing, and testing data is just to test with the data that we have not used it for training. We have one complete 100% data set, and in that, for example, 80% I am using it for training, which algorithm understand, and it has already learned what is the meaning of the x value and what is the y value answer. All right. And part of the data we kept separately, that we are not told that this data exists. So this separate data, 20% of data, which is not being told or which is not being trained to the model, we will be going to give it to it as a testing data, so that it can answer the questions on the data which it has not been trained for. If it tries to answer that, it might be checking it. I mean, we might be checking its accuracy in terms of models learning abilities. All right. So that way, you can divide the data in three parts or two parts: training data and testing data. 70 to 80% based on the data set size you have. Okay, in terms of data set, you're getting it from your data source. 70 to 80% of data goes into the training data. That is the standard number. Okay, whenever you divide your data, you just make sure this number. 70 to 80% of data we use it for training. Set which is used for training the model. Validation is also known as a development set and is used to avoid overfitting or underfitting situations. Enabling hyperparameters earlier. hyperparameters are the parameters that we tweak in an algorithm to increase the accuracy of the algorithm of the presented data set. Okay? So whenever I have evaluated my model, but it is not increasing its accuracy, it is 70% accuracy it is giving, but 20% it is not recognizing properly. So in that situation, what we do, we try to change some parameters in our algorithm so that it can increase its efficiency from 70 to 90% to 95%. Okay, that's more changes that we do or tuning we do on the algorithm. So we do it by changing the parameters itself in the algorithm. Alright, so changing those parameters and tweaking a little can be called as hyperparameter tuning. Okay, why do we do that? To increase the efficiency of your algorithm. You have given the data which is not at all, relevant to this model. And underfitting is you have given the data which is not at all useful to the model to learn from it. Alright. So if you give a sequence data, like 1, 2, 3, 4, all of them, if you give the data, so that could be an underfitting data because that's not at all useful for learning. If you randomize the data and then ask a question, you can learn from that randomized data. If you give series of data which is obvious in nature, then such data is not at all useful for the machine learning process. That you need to understand. That's why you have to randomize the things there. Okay. Valuation data is used during the model evaluation. 10 to 15%. Usually it is 20%. That we do. Usually we take it 80% of the training, 20% is for testing data. Okay. Then it is crucial to randomize the data, as you are saying. Randomize the data. Set while splitting the data to get an accurate model. Why are we saying this? Do you have any thought on this? It is crucial to randomize this data set while you are splitting the data to get an accurate model.
Randomize the data set means, so if data is collected in any order,
Correct.
so it will disturb the orders. So
It has to disturb the order and randomize it.
Randomize the things.
Okay.
Then whatever the order ML identifies, that will be correct. So it will be ML will not be order biased.
Correct.
So the existing order will not be having any bias on the ML.
Agree. So why do we do that in the first question?
It's like randomized data is like reshuffling the cards. You have plays.
Right. Agree. So what if I give the regular data, like I have the words which are dictionary based sorted and all the numbers are sorted from lower number to higher numbers, it's completely sorted. I will give it to the algorithm. It is saying you randomize the model will be created very well. And when you give the regular data, it might feel difficult to find the pattern. So that's why we need to give the data which is random so that it can form its own logic, okay, in its model creation. That's why we need to give the data which is randomized. If you give regular data, it is not able to find its logic to link different data. And one more reason is when you actually randomize it, some of the data which is if you have ordered it, it might have become part of 80% of the data. Now, as you randomize it, but some of the data from your 80% order data is also available in testing data, and testing data is also available in the 80% of training data. So randomization has shuffled the data, and the data set is now normalized in terms of randomization of the data. So now you have the data which is random, and that's why your model is able to understand the pattern of changes that are happening in the values that are available in the columns of any features, each feature that you have in the Excel sheet of any format. You get that? Okay. Theoretically, just try to understand when you take one column, just take one column And you just understand that from 0 to 100 I have written the number. And if I tell you, you please find out the difference between each number and tell me what is the pattern. What do you say? Every number is next number plus one, you add it, you get that. So what logic you form to get the next number? Plus one is the logic fix. And if I ask you from 0 to 20, you have regular numbers. From 21, you have numbers, one number skip till 40. From 41, two numbers skip. From 41 till 60, two numbers skip. From 70, 71 or 70, not 71, 61 till 80, three numbers are skipped. So now can you see a pattern? Now your logic will change. Earlier your logic was just add plus one, you get all the 100 numbers you are saying. Get it? Now your logic will change. Your logic has to be a little complex now. If any number you want, you are asking me between 0 to 20, the model says I understand what he is asking. He is asking below 20. I will just give him plus 1. Next number you want, right? You are asking 70. And you give me the question and you are asking next number. I will give you 18. If I ask you 65, you start skipping 4 numbers and giving me the next number. Now you found out the pattern. Now you have the pattern as well as the logic you have formed. So that logic that you have formed internally is the model. You understand now? That's why we are trying to. I have just put you simple numbers, and now you understood now. So think about those real numbers that are randomly shuffled, and in that, you have to find the pattern. That pattern is little more complex than what we are thinking. Alright, we just took 100 numbers and we are able to understand this now. And we are able to possibly give that logic also. If I give you 1,000, 10,000, 1 lakh numbers, in that to find those changes and the numbers is difficult for us. So computer can understand that pattern with the help of algorithm. You understand now? Okay. So that logic it is finding out by itself. I am trying to store that logic as a data abstraction. That is nothing but the model. Whenever you ask a question, it will take that question in its model and try to use its logic internally, which is its customized algorithm. And it has created that customized logic algorithm with the help of data that you supplied. Alright? So with that logic, it can give you the accurate answer. And the answer may vary because its logic is not completely mature when it is getting trained. When it is completely trained, it has formed even the small logics which you have created. For example, I will show them the photo. First time I show the photo. It try to understand some features. I will show them many photos of people, how humans will exist. So it has to identify between the humans and the animals. Okay. Then it will identify all the small features of humans when we train them with the multiple photos of humans as well as animals. So it will find out what is the actual pattern or common pattern that these many things are definitely there, and some of them maybe extra things might come. So those things it is going to record in terms of its logic data. That model is going to be experiencing its own changes based on the data that are given. So based on data, it is internally designing its own logic called model. Alright. Generally, we call algorithm as a step-by-step process or procedure to solve a specific problem. Here also we have spoken about, we told that initially I need to have a problem, then only I am going to solve the problem with the help of features. Algorithm also says the same. You give me a problem, for example, I want to sort the numbers. That is my problem statement. You write an algorithm step by step. How do you sort the numbers? Same thing. So what is the difference between what programs you were writing earlier in Python and what about the machine learning programs? What is the difference between them? And what is the difference between the model and the algorithm? Algorithm says I will solve the problem that is given to me step by step. Your machine learning model says I will solve this problem with the help of data you supply. If you don't give me the data, I will not be able to learn what data is all about and how the data is varying in its pattern or how data is changing in the next records. Okay, so your algorithm has a fixed steps of number of steps which it has to follow to solve the problem. Your algorithm is having fixed number of steps to solve a specific problem. Okay, with the given data. Right? Step 1, step 2, step 3. This is our fixed. Your mathematical equations, numerical formulas. When you do the numerical mathematical equations, you have number of steps and you get the data at the end. It is not same in terms of machine learning algorithms. In machine learning algorithms, as we are saying, it is completely depending on data. So it is going to learn the data and changes in the data or variation in the data, and that changes will be stored in the model. That model is a mathematical model which understands the changes and which creates its own logic, and that logic will give you the algorithm. What kind of algorithm? Customized algorithm. Who customized it? You customized it. How you did that? By providing a specific set of data. If you give different data, different algorithm will design. So that customized algorithm, what we are calling it as model. Alright? So that's why whenever we supply the data to the model for machine learning algorithms, we need to be careful about what kind of data that we are collecting, and is that data is ready to be supplied to the algorithm, because it learns from that and creates a logic model. Is that alright?
ML machine learning engineering will be valued on the basis of his understanding of the data.
Machine learning engineering.
Engineers.
Engineering
will be valued on the basis of his understanding of the data and which model or algorithm fits that data correctly.
Right.
Okay. So, what you said here contradicts that statement.
Okay.
Here you are saying that the machine will be understanding the data and it will generate its own ML for that.
Right.
So how the matching between yesterday and statements?
Here we are saying when we collect the data, we are just generating some data that we wanted. We have been presented a problem. And for the data that you are collecting, which algorithm you have to use. When you select that algorithm, then only the model, which is customized model, that's getting created. Without the algorithm which handles this data, it cannot create a model after training.
So model is a customized algorithm.
Yes, to create that, we need an algorithm.
That algorithm, the engineer has to decide.
Correct.
So if engineer selects some other wrong algorithm, then it may not fit the data correctly, or output will be
efficiency. When you do evaluation, you definitely have a chance of switching back to the next algorithm. Evaluation is the examination of the machine learning model. When that model is not predicting properly, so we'll have one more algorithm ready only. One more algorithm is giving this much, this algorithm is giving this much. We have comparative analysis. Then whichever algorithm is best, that will go ahead.
In that case, let's assume there are 9 algorithms. So in the program itself, he writes all the 9 algorithms.
We can write it.
Okay. We will write that. And we will plot the performance of each and every algorithm.
Yes.
So wherever the result is maximum or optimum, that will be written in the program and we will delete other lines.
Yes, obviously that can be. Yes, that's how it has to be done in the companies. When you wanted to design algorithms, you have whatever choice you have. Yesterday I told you this have to eliminate. So you have to eliminate with the help of evaluation. Like how you evaluate students on a basis of marks, you evaluate and give them the one rank. That's why we are evaluating in here also. And it does not mean that you are evaluating by based on just first run. Not run in multiple data sets, then you have to evaluate it. So that which algorithm is learning properly, or see, sometimes the algorithm may not learn at the initial first 2 or 3 phases. It might learn from the third step, or it might learn from the fourth step. So it is based on the data that is supplying and the parameters that you have tweaked. Based on that, the algorithm might change its behavior. So we have to give some chances to the algorithm, like 2 to 3 chances I will give. Even if it is not giving proper output, I will tweak the algorithm's parameters. I just wanted to see whether it increases performance. So that way, I just have a mechanism of altering the parameters and changing the data set. Then I'll see the performance and I'll go ahead with one of the algorithms. That's how we just try to collect it. Am I clear? We have algorithm, then we have a training with a model that is selected. My initial, you might have seen earlier that whenever we select an algorithm, we create an algorithm's object. So we call it as a model, and model dot train or model dot fit we were doing, right? And in the fit we are going to give the x and y values, right? And we will be going to train that model with the help of model lecture. When you put a dot and say fit, that means you are operating on the model with the help of data. So you are creating a customized algorithm with the help of existing algorithms. Because your algorithm is having mathematical equations. Those mathematical equations need data from outside. So that will be given by your fit function. Okay? So that's how model gets trained from the algorithm's angle. So without algorithm, it cannot do itself because it doesn't have any programming logic like how you were doing earlier. You are writing if conditions, you are writing less than conditions, and inside it again you are writing for loop. So all those programs are not there. Have you seen that? Nothing. You are not seen. Even it is, we say that it is a more powerful analysis capability, but we are not seeing those things in machine learning algorithms, machine learning programs. Those things are there themselves. Alright. So if you wanted to see them, we just have to put a control. I just have to press control and I have to take my cursor there. This hand kind of a gesture will come. Then I have to click onto that. Then I will be inside the class called linear regression. This is going to receive these things. That is ordinary least square linear regression. Okay. This is going to give more accurate results with respect to linear regression. Okay. This OLS is the short form of it, and this we can use it instead of linear regression later. So as we learned theoretically linear regression, that's why we use linear regression algorithm. Later, as an advanced thing, we can go with the ordinary least squares. Will be the name of the algorithm. Remember this. All right. So this is your algorithm that you have created. And this is the function that you are calling when you say model dot or linear regression model dot something. All right, you have done that earlier. Linear regression LR dot fit your doing. So it is expecting something. What it is expecting? It is expecting these things, and you are also giving those things. Fit you are writing inside those things. You are writing these things. So this is the function which is actually expecting it, and you are giving it. And internally it is trying to do that. So it is given fit linear model. What parameter is expecting? It is expecting X value. What it is? Array like a sparse matrix of shape n samples, n features, training data. And what about Y? Y is my array like shape or samples on n targets. These are my features and these are my targets. Target values will be cast to X's data type if necessary. Yeah. Then it is going to have its self dot validation parameters, then self dot n jobs. So it will be a complex logic that they'll put it with the linear models logic or formulas, and they'll do that. Yeah. So till this one it is there. So this whole program will actually create a mathematical model based on the data we are consuming. Alright. So this is your algorithm that we have not seen it earlier. So this whole program you cannot write it. You cannot type it and say I have written the algorithm. So this is hidden inside the name that we have created. So what we did, we just hold a control on this and we went to this one and just clicked it and inside the algorithm. Whichever algorithm you want to analyze, click on that, there will be inside the algorithm. Right, analyze. So that will be my base class, and this is what the fit function we call it. All right. So that is my model training. It is crucial to randomize the data set while splitting the data to get the accurate model. And what we did in our algorithm, we have divided. We are not divided here. Training, testing data. Yeah, here we divide. Train, test, split, and then we are going to divide. Training, test data, you have taken it 30%. We can also mention train size. Alright. So if you look at this parameter, it is also allowing you to specify train size. Presently, we have specified test size. Okay. And if you want to shuffle the data, you can also ask them, do you want to shuffle it? Okay. Do you want to randomize it? Integer. You can also randomize the data while dividing. So this is the seed for dividing that. I hope you understand that. Random state instance or none, default is none, controls the shuffling. Controls the shuffling applied to the data before applying the split. Before splitting the data, just shuffle the data and then split it. And divide them and give it to the training and testing data. Passing and aim for a reproducible output across multiple functions. Okay. So these are the things. So presently we have just given, see, one parameter if you specify, other parameter is indirectly given. For example, I have already told test size I want 30%. You want these 30%. So how about training data? 70%. It's understood. So that way, it is going to take training data, testing data based on the number that you are providing. Alright, you just have to treat like this and try to understand. Okay, so data can be randomized using scikit-learn in Python. Alright, so this parameter, train test data, train test split, we have taken it from SQL model training. This is really important. Whatever steps we are learning are process or procedure to build any machine learning model, Right? These steps are very important. You try to understand the pipeline of from the start till end. If you understand this, only once you have to understand this for your whole lifetime. If you understand it once clearly, then further you will do it by yourself. You start learning by yourself. Alright? That's why everybody is physically here. Okay? Whenever you have question, you can ask. Okay, then we are ready with the model. So what you did here is you created a model. So model training is been done with the help of fit function. So when your training is done, you are ready with the model. So now evaluation of that model has to be done. Okay, what we do in evaluation? After the model training, validation and development of data is used to evaluate the model. Development data is your testing data, is used to evaluate the model. To get the most accurate predictions, to test data may be used to further evaluate the model. So test data, we kept it separately to test this model earlier. and we took 80% data for training. Now 20% data that we kept separately, now it is being used in the evaluation of the model. Confusion matrix is created after the model evaluation to calculate accuracy and precision numerically. Numerical number will be given to you in a list format, and you can consider it as a matrix itself. So that matrix will give you the accuracy of this whole model, and that parameter you can read it like a matrix, right? Okay. Confusion matrix could also be visualized on a numerically. If you plot them graphically, you will understand that how a model is getting trained and how it is getting evaluated. And how do you evaluate a model generally? How do you understand that it is working correctly? Initially, we have collected some data. Those data we are calling them as features. Okay, and those features in one line, I say one entity's features are. For example, as I told you an example, agriculture land. I am trying to analyze soil. So in that soil, there might be some content, and one record is one place soil testing. And after that, I will be writing some conclusion at the end. So this soil is healthy or not healthy to grow or to cultivate. So that last column will become my target features or target values. Alright, I have a features, I have a target feature. Okay, so once I have that, I will be considering 100% data as my collected data. In that, I have divided 80% for algorithm. I have trained it. That story is over. Now 20% data that I have collected and which I kept it separate, I am going to use it here. And now, how do you say that the model is predicting properly? And this, if I give the soil parameter, it has to tell me whether it is healthy to cultivate or not. A specific crop I will give it, like wheat I want to grow. It has to tell wheat is wheat can I grow it in this soil by using as a parameter. Now, how do you consider? For example, you have about the machine learning. If there is a person who looks at the parameter and say, okay, this is okay, and you can grow. If the person is detecting like that, what he is looking at? He's just looking at the ideal parameters for a weed. What weed has to grow? I mean, wherever the weed has to grow, whatever required content it needs, supporting content it needs. Alright? So supporting contents are already available in terms of the values. Alright? So what is not there when we are testing is the answer. This is the target is missing. Alright? We are ready with the features. So what we trained with? We trained with the features and the targets. Now we are just looking for the answer by giving only the features and the X values. So how can I evaluate it? How can I evaluate the accuracy? Okay. No, I just want to make a decision. I'm not going now. I just want to make a decision.
We have to take those requirement parameters from the every university.
Okay.
And we have to match them with the observed soil parameters. Okay. So, if observed parameters of the soil or in the they can provide the range of the requirements of the weeds as provided by the university.
Okay.
Then we can grow with this.
Okay.
So the observed soil parameters they are not matching with the requirements of the university. Then in that case we can't grow soil weeds.
Okay. So the question is, how do you tell the model is working perfectly? Is the question. Because we are in an evaluation and you have to check, I have trained it, I have given the data, I am considering that it is ready. How do you say that it is ready? Is the question. By testing the model with testing data. Now, after I have tested it, it is giving me some answers. Now, how do you say that the answers are correct? with the question.
Initially, we have a value answers.
Answers initially we are ready with what answers we are ready with. Initially testing questions were there and answers were also ready. Yes. So let's get back to the program that we had. Did we had here? Okay. So we were using X test here, which we are using for evaluation. And to check predicted values are right or wrong, we can check against these values. Because these are my answers, which are, I already know the answer. I am testing you whether you will give me the right answer or not. Okay, so these answers I will check it with the predicted answers and match it. So that is done through a scoring functions. Okay, of the model. So that will be my evaluation that I am expecting it to give me an accurate answer. Okay, so that would be done with a confusion matrix, which will give me an accuracy and precision numerically they indicate. After model evaluation, our model enters the final stage, that is the prediction. I hope you got a little idea about model evaluation. Okay, we just need to evaluate it with the previous values and the new values we are getting. And what is the difference between that? Will give you a percentage of error percentage as well as with respect to the successful prediction percentage. If it is not accurately predicting in a greater percentage, you have to go back to the previous step that we told tuning. What we told? We told hyperparameter tuning. What it says? It's a technique used to combat overfitting and underfitting. And here also we told validation data is used to know the development set, and development set is used to avoid overfitting and underfitting. That is enabling the hyperparameter tuning. So when you do that, again your model will increase the percentage of accuracy it is answering. Okay, that's how the model evaluation will not stop here and it will not go immediately to the next step. It might change the parameter, again it can train the model, again it can evaluate. My percentage is increasing the target because I just made a small change. I want to check. Again I will be going to loop it here. So the previous team and this team will try to intensively look for this evaluation. Once the evaluation reaches to the 95% or 99%, then they go for next thing. Fine. So here, actual prediction will start happening. In the prediction phase, developer deploys the model. What does it mean? This keyword means
in the prediction phase, he will subject it to real world applications.
Okay, but what is the meaning of deploy? Have you heard it somewhere? Where you heard it? What is
If we
it?
go to real-time usage.
Efficiency, okay.
Real-time usage.
Real-time usage, okay. Yes. Others? What about deploy?
Deployed in the sense
You,
it will be given to the customer
exactly.
for the usage.
Exactly. So deploying is the process of installing it or giving it to the user to use it in a real world conditions. That is deployment. For example, if I have created an application, I have to give it to my user. So what I call it, that whole process of delivering the product to the user, I call it as I'm deploying it. I'm deploying it. Or I'm delivering it to the customer. So I'm delivering it to the customer, I call it as deployment. Deployment. Right? Okay. So in the prediction phase, developer deploys the model given into the real conditions. After the model deployment, it becomes ready to make predictions. When it passes the prediction phase in the real conditions, then it is ready for the commercial use or actual usage of the model. Predictions are made on a training data and test data to have a better understanding of the build model. Predictions are made on a training data set and testing data sets, both of them. And we are ready with the model now. The deployment of the model isn't one-time exercise, obviously. as more and more data gets generated, the more model is required. Else it get what you can say obsolete because of not updating it regularly. It is same like how you do software updating a mobile phone or any of the applications. That's how it is. It has to be updated. How does it update? With the new data, you have to train it and evaluate it. Again, you have to deploy it. The conditions. All right. So these mechanisms that we just now see are actually your 7 steps. Okay, only 6 steps is there. 7 steps. Whatever we have are actually the 7 teams which are working in your company, and one team is having, for example, 10 to 20 people. You consider how huge the work is, and the work will not stop because the cycle will not stop for one customer of the company. All right. So you are working on a small thing in a bigger project. Can you see how big the project is? You cannot alone sit and do all of them because each phase that we have explained is having a lot of functionality. Each functionality, to complete that functionality, you need to remember and understand, and also learn how to use the different packages functions. If you are only working on the visualization, you have to understand all the parameters and all the functions firstly of the Matplotlib package, and all the functions parameters you have to remember. For example, one function I tell you, in the function itself there are parameters available. Okay. Compulsory as well as optional. Both all the parameters you have to understand because you have to have control over the functions. But take control over the functions, and then you have to tell that I will. If you tell me the problem, I will solve with this function because I understand this is parameter. I change it, then the problem will be solved. So that much deep you have to understand this parameter and you have to work on it. So it is not that you understand everything and you do all the things. No, you have specialization in one thing and go ahead with that phase. So in these phases, you have to choose your place where you fit in and go on deep dive into that and become a specialized person in one phase of the machine learning development. All right. Okay. So that's what we wanted to see. We'll just see a video that I just kept it in some other thing. Which one, sir?
It was a red color videos.
Red color video.
It was fully, mostly it was full of red color things.
Okay, let's see. It was a beautiful video that I have shortlisted for you to see. Let's see if I can find it here.
Or it might be open in one of the.
Yeah, this is Google's video. They can explain it better. Yes, you can see this thing. Here also you can understand. So they explain it with a different angle of looking at a classification. They see classification problems. They have this, and the problem they have chosen. The problem they have chosen is your machine learning model has to identify by looking at a class or values available in the class by testing whether the color of the liquid and percentage of alcohol the liquid is having. Those numbers have to be used to fill the data columns. When the data is collected, then you have to tell in the Y column whether it is a alcohol, whether it is a beer or whether it is, what is that? Wine or beer. So that you have to tell in a Y column. That is your answer. So your algorithm has to identify that. Okay, initially you will give this much percentage of alcohol, this much percentage of this is the color. So this is this thing. Will be my training data. So at the end, I will just give you the percentage of alcohol and the color. Then the algorithm has to tell whether it is a here or alright. So that is the problem that we are solving. And yeah, this is the one. Color and alcohol and beer or beer wine. They have to tell and you have to collect the data. And how do you collect the data? Randomly you collect it from the different bottles and you just check and measure. And you have ready with the data. And here you have to choose the model. Since you have only two features, what are those? Alcohol percentage is the two features, so that's why only two features you have. So you can go for linear model, small linear model you can choose. Okay. So this will be the equation that you very much familiar with. Do you understand this? This is my output, this is my input features, this is slope, and this is my intercept. Sometimes we can also call it as biases. Okay. So this I can call it as slope in terms of plotting, and in terms of data. If I speak, there are multiple such, for example, such like mx plus b, such 1,000 values are there. Then such 1,000 values we will create a matrix to evaluate it properly. All right. Okay. So that we can evaluate them with a multiplication of two matrices. Addition of two matrices. So matrices calculation is easy to do rather than evaluating the two equations, simultaneous two equations. Getting it is difficult to solve two simultaneous equations in computer. That's why we consider collecting all the m values in one place, x values in one place, g values in one place in matrices, and it is easy for me to pick one value from the matrix, another value from the matrix, and multiply them and give the answer. Alright, that way I will be able to create, evaluate equation easily. Getting it? So presently it is shown. We have weights, we have biases, and all those things are there. Okay, let's look at the video and let's understand what it is, what they have to say. I think it's a 3 minutes video. Hmm. 10 minutes is that? Yeah. Sound. you just merge them into each other. So these are the 7 steps that you have to take. Okay, gathering data, preparing the data, gathering is just correcting. Okay, here you are removing the errors from it and making it ready. And here you are choosing the model, how you are choosing the algorithm to use it. And here you start training based on the with the help of the data and the model. And here you evaluate the model. And if the evaluation, if the model is not passing your percentage of learning or your expected percentage, then you tweak the parameter or change the parameters in the algorithms. And then you do for prediction. Alright, so these are the 7 steps. So this is the playground for checking your model as well as giving the inputs for the neural networks. Okay, then the URL is playground.tensorflow.org. All right, playground.tensorflow.org is the new one. Okay. Any questions you have? Have you understood what he said? All the pages clear? Okay. So whatever he has stored in the video, there's a description onto this block. You can understand. That's the data collected for y equal to mx plus b, and in that equation, they have the inputs as m is the slope, p is the y-intercept, y is the value of the line, and the position x. So all those values will be used to train, and they have your m and b as biases, m and b as a biases, and there is no way that affects the position of the line, since the only other variable that we have is x, which will vary the values. Okay, our input and y will vary based on the x changes. So x will be your features that you already have it. Okay, m and b will be constants, and x is the only variable that you can change it. Based on that change, you have a change in the y. All right, in the LHS. And this will happen. You have a training data, you give it to the model with the W and B. Okay, then weights and biases, and does the prediction. And based on prediction, you evaluate it or test it, test and update the W and B, and then you again prepare the data with the updated W and B, and again you train the model, and again increase the accuracy of that, and again test the model with the prediction. That cycle will goes on. This process repeats each iteration or cycle of updating the weights and biases called training steps. And then the evaluation happens. Once the training is complete, it's time to see the model is any good using the evaluation. This is where the data set we set aside earlier, that is your test data, will play a role here in evaluation. And we said a good rule of thumb, I use of training evaluation split somewhere order of 80-20 division, 80 for training, 20 for testing, 70 for training, 30 for testing. Much of that depend on the original size of your data set or source of the data set that you're taking. And parameter tuning. Once you are done evaluation, it's possible that you want to see if you can further improve your model. Okay, with the training. We can do this by tuning our parameters. There are few parameters we implicitly assume that when we did our training, and now it is good time to go back to that place and test those assumptions that we have tried as a by default assumptions and change the values. And there are the different data that you have that you are going to give it to the model and see if your prediction could improve. This is one more parameter that we have to see in the algorithm. Learning rate. Okay. Sometimes we also call it as R square. That we'll learn in the next modules. This defines how far we shift the line in terms of linear regression. We talk about the line that we are drawing, the blue line that we saw earlier. Not accurately dividing the partition between the two values. Okay, so now it is accurately deciding how the division has to be done. So that change that is happening, difference between the previous line alignment and the next line alignment will be the learning rate. Okay, so that's how it goes on with respect to the prediction. And in the prediction, obviously, when your model is ready, you use the model and go for the prediction, and you predict the outcome. You take the data. Okay, this is the input actually. New input, new value, questioning. You have a question, you give it to the model. Model does the prediction and gives the answer. We finally use our model to predict whether a given drink is wine or beer by giving its color value and alcohol percentage. Color value and alcohol percentage. NM is nanometer. Okay, nanometer is measurement of wavelength. Color of the light measured with respect to wavelength. So nanometer is the wavelength length. Okay,
It will be scanning the color through nanometer or RGB readings.
Maybe any device it is reading, device it is using to find out the color of that, and that device is giving in nanometer. Any device you can use it. The length of the or bandwidth, as we say, to measure that width of that color band, we use this nanometer. So with that value, the model understands what it has to do with that value, where it has to map that new value, and it does the prediction that it is this drink is. Big picture, overall, the power of machine learning is that you are able to determine how to differentiate between the wine and beer using your model, rather than using the human judgment and manual rules. You can extrapolate the idea. Extrapolate means use the same idea presented today to other problems domains as well. Those who want to use this model to other places, they can do follow the same process where the same principles apply. Gathering data, preparing the data, choosing the model, training the model, evaluate it, hyperparameter you tweak it, and then you have predictions ready. And the playground that they were mentioning is here. Okay, tinker with a neural network. This is neural network actually. You don't have to use it presently, but I'm just here to show you the parameters that you can use it, and you have to understand those parameters to understand the algorithm's learning abilities. Tinker with a neural network right here in your browser. Don't worry, you can't break it. We promise it. You just have to use them, and it doesn't allow you to destroy anything, because this is one session that we are using. That will be on your browser. It doesn't disturb their values or data. Okay, this is epoch. This is number of times you have looped it. How many times you want to loop it? That you can mention it here. This is your learning rate. You can fix it. That how much change it must take. And this is activation function. I have told you there are sigma and there are ReLU, as Chandrakant sir was mentioning. ReLU was one of the activation function. Activation function I have told you, which is having its what you can say minimum value to that value of the cross it. Like we told earlier that tossing of the coin was giving us a probability of 50%. Neural network. Okay, so the decision making function we call them as activation function. All right, so many different types of functions we have which is activate. And you will see them in the algorithm, in the machine learning algorithm. So let's understand these parameters. Then we have the regularization. So this is L1 and L2. Regularization rate. Then you have problem type. What problem you are trying to solve? Whether you are doing a classification or you are doing a regression. So based on that, you will be given a values. This is my regression problem, and here it is giving me the data. Which data do you want to use? Do you want to use this one or do you want to use this one? You have the data being visualized here. They are told, right? Whenever you take a data, initially you collect the data, you visualize it. So visualization is directly given to you. You are presently data like look like this. And they are asking whether you want this data or this data. Let us take this data itself. You have a ratio of training and testing data. How you want to divide? So what percentage they have told?
So
75, 80, 20. 80-20 will be the presently it is asking about training data. So training data will increase it to 80%. You can see visualization is changing. So maximum they have given 90%. You are allowed to use 90%. So let us use it 70%. I mean 80%. This is the 80% of the data. Can you see? This is 10% of the data for training. Just have some dots which are very far away from each other. So now you can see some patterns. Even if I ask you to draw something on it, you start drawing by joining the dots. Okay. So noise is the error percentage that you have. That means each dot is overlapping on each other. Each dot is overlapping on other dot. That is the error percentage that we are increasing. Okay. So you can reduce the errors, which says very less errors you have. I mean the overlapping of them is very less. And you have batch size, test loss. Let us keep it one batch. The data is getting regenerated with the help of this one. And then the features. How many features you want to activate, you can activate it by clicking on it. Presently, I have only 2 features. And which properties do you want to feed in? Use. How many neurons you want to use? You can reduce it or increase it. How many number of neurons you increase? Those many layers will create and they will evaluate your model easily. But they take more time. This is the output from one neuron over to larger. So where they are operating, they are just getting. You wanted to see the bifurcation between the 2 groups, right? So presently this neuron is working on dividing like this, and this neuron is working on dividing like this, and this neuron is working on dividing like this. So each neuron is working on the data set differently, and all of them will decide one thing, and they give it to each of them in the next layer. So this is the next layer. The output are mixed with the varying weights show by thickening the lines. Alright. So that way we will have the different neurons which will give us this vertical and this horizontal data being mixed, and it will create these kind of variations. So these variations will give you the next patterns. And if you increase it, the variations will increase, and you'll see different variations will give you different values. Okay, so that's how you can just see, show test data, discretize output. These are your input data, I mean test data, and the background is the training data that you have. Yeah, this is the simulation. You can plot on. This is ReLU. I told you, right? ReLU or sigmoid. Sigmoid is just kind of a curve with not. ReLU will come like this with almost 90 degrees. This has become 90 degrees from somewhere. So this epoch is how many times it is getting trained, how many times it is looping. Okay, so then it is getting looped.
Any change happening in learning rates?
Yes, that is happening.
yellow and blue line is changing, sir.
And not this one. Here you just have to observe. So how much you want, you can keep it and you can stop there. And you can use your testing data to see what answers they are getting. So this is what it is showing the data to you. This is the line that they are trying to divide the things. Whether it is this feature or this feature, they just wanted to bifurcate. The data that they have used is random data, the points, and they're just trying to do regression on that. Okay, and if you do classification, so you have different types of data like this. So you can use the same things, and you can just try to see them, and you can start playing with the same thing as you have already activated the tanh. So this is the one. I just change it to sigmoid, and I just play it again. Yes, the line is, you can see from the different lines it is trying to become, these are my weights that are getting changed. It is 3.4 now, it is 3.4, it is keeping it 3.4, this is minus 1.1, this is minus 3.0. Okay, it has already trained something. It has regenerated, and let us see. It is 2.4, 2.6, 2.7, okay, 2.8. So the weights are changing, 2.9. We have minus 3.8. Their weights are changing, and this will be the final output. I mean, these small screens, as you see, they are actually changing that. And they see that to bifurcate this or to separate those two groups, this line must be the accurate one. They started from nowhere. Can you see that? They just have this thing and it will come down till here. Can you see the line is moving? Can you see? Which one? They're just trying to align themselves. The line is changing. Okay, the line is changing because of the m values that we have here, weights. You can change them also. The values that you have. If you click on them, and this value is almost 4.6. I'll make it 4.6. So it is having a different behavior here. Okay, so all of them are giving some values, some weights. All the lines which are coming from this place are having the different values based on the weights they are generating, and the activation function that has been applied onto this one, and they will receive, and they will again generate those things for number of inputs that we have to give it or send it. That's how neural network will help you in deciding the outcomes based on the neural network computation internally in the hidden layer. Okay, you can see your values are changing, and here you have the function which is changing completely. So ReLU, this is sigmoid, this is tan H. We have linear. Okay, I hope you have understood the steps now. Okay, shall we go back to the programs? Okay, now similar to the previous learning that we have done, based on that, what parameters we can use to generate the similar model? The student, whether it's here or it's mine, and they have explained all the 7 steps how to follow. So we need to follow all those steps and we need to create a model. So what problem we can choose to go ahead, which has 2 parameters basically.
Very lot of noise.
So parameters, we have the parameters. Tea, tea or coffee. Okay, how do you identify what are the key KPI? What are the KPI that you have? So for the greens that you have, color and alcohol percentage are the KPIs. So what are the KPIs? You identify the KPI along with the column, right? Then we discuss.
Cat or dogs.
KPIs.
With a dog will be having a tail.
In front photo is not front photo is not. That's
It sound like
sounds. Sounds. Okay, KPIs. Sound versus
Height can be KPIs.
height.
Height.
Height of?
Height of dog and
Dog.
height of cats.
No, it's very much usual that both of them might have same. More personal besides they have same, then the model fails. But to identify.
Or
Shall we
sand,
check?
sand and cement.
Sand and
Cement.
okay. So what problem we have and trying to solve?
So differentiate between sand and cement.
Okay.
Parameters are this cement is amorphous. It is in crystalline sand.
Number
Color difference is this. Sand yellowish or cream color.
color value we have. Okay.
Color is this. And
Yeah.
sand it comes in small particles of 1 mm size. Whereas the cement is a powder.
Okay. So
So 2 parameters are there.
2 parameters here. Color and
Size of the particle.
color and size of the particle. Okay. So it has to tell the Y column whether it is sand or cement. Okay. So data, how will we, what are the sample values that we can have the data? Sample values, for example, in terms of what we can measure them. Like we are measuring the color in nanometer and percentage of alcohol in terms of percentage. Also.
One size you can measure in on the space in mm,
Okay.
in millimeters. And color we can measure on nanometer scale.
Still particles are
Like
in mm.
Yes, sir.
We can have, okay, understood. Next, cement.
And by their density, sir, weight.
Cement in microman 10^-6.
Yes,
So
sir.
they are measuring fineness of the cement powder in the micrometers. They are measuring the fineness. How fine it is. Sand size was measured.
Limited to the particle size. This is the limit. Maximum it can have 7.5.
If it crosses beyond 7.5, sir, then it becomes a particle. So then the model will not be able to differentiate between the sand and the cement.
So the sand particle also having this much size. Then also it is, obviously it cannot come to this size micrometer.
Then that parameter fails.
So we have to manually check for some sample values whether we can identify it. Then we have to tell our model to get trained in that knowledge. So we have to identify the data first. Then we identify the algorithm. Data along with the features.
And also, sir, when light is thrown on both the sand and cement, sand particle of one particle will fall on the other particles. So in the image, there will be black shadows will be there.
Okay.
So by the color also, sir, if that black shadows are there, then obviously that is a sand. Whereas that black shadow
Using
Engines also differ. Car and bike.
we need only two parameters presently. You can go for multi-valued regression, multiple regression. Presently, we need only two things so that you can decide and what is the one is sample modification.
Yes, sir. Wood and dust.
Wood and metal. Okay. KPIs.
It is iron metal, sir. Containing iron metal.
Number.
Thousand.
No, these numbers. 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 And we just learned one example. We wanted to do our own example on this. So we have color and alcohol, and at the end we have wire. So you need to find out the problem you have, and that problem must be solved with these two parameters. That problem you need to identify and the key features. Key features are ready, then you also have the answer ready. So those answers and these questions can be used for training. Some of the part we can take out.
Lemon and orange.
KPIs, color and
A color and percentage of citrus. Both are citrus.
both are citrus fruits.
So percentage of citrus.
Okay. So color orange and yellow.
Yellows.
Orange and yellow.
but percentage of citrus how is it measured?
Percentage of citrus to the same level.
Same.
Parchment paper or the gateway paper. So can be the measure. There will be devices to measure. Devices to measure. So we need to collect and see if we have the data in the Kaggle or somewhere. Okay.
I have to find the difference between sambar and rasam.
So KPIs.
It is one is pH value of both sambar and rasam.
pH value depends on the nitrogen concentration. Water.
Next, in soil testing, we get the pH values. Similarly, here also we have the pH values of the rasam and samar. Samar will be having the particles, whereas they will be assembling rasam.
Yeah, we can find out. Citrus fruit classification. Orange or grape classification. Yeah. We have the name, diameter of the fruit, weight, color that is red, average red reading from the RGB scan. Values should be from 0 to 225. This weight is in grams, diameter is in centimeters. Name is just orange, either orange or grape. Any two values are there. Then we have green, the RGB scan, and it's also RGB scan. And this is the data analysis that they have done on this one. This is the range that they have, range of values. Yes.
Diameter, we have to feed manually or
No, it is there. System, it has it. I mean, we have to obviously measure it whenever we record the data. That's what the data collection is there. So, based on the data that you're collecting, if you have a device or you have something, so you collect it. So, presently they are already collected and ready. You just have to use them.
on I thought they will be scanning the diameter through scanners.
Equipments would be used to measure that. Because for the cylinders, what we used to measure?
Cylinder.
Same rule.
Calipers.
So formulas.
1 inch caliper.
Yeah, 1 minute.
So there is a formula.
Measure the physical pipe diameter.
I diameter, sir. What is
Internal diameter and outer diameter.
there is a like
I understand. Okay, so this is the data analysis that has been done from 2.96 to 16.0, but the maximum values of these things they are showing. Okay, as we did earlier, the data analysis, I mean, macroscopic value. So that this they have done on that. All of them, all the data. Okay, so we have downloaded them. How many data? We have 99,757, around 1 lakh. 1 lakh records in that. So,
Those many things they have measured the diameter. Sir.
no, I think I have. Okay. 17 lakhs. So I generated the values. 17 lakhs is the number. Here they will tell the exact actual number, right? Here it is saying 10,001. Okay, they are showing the sum here. This would I would have done. Okay, this is 10,000. Here when I did, it is showing the sum. Here I have to see count it. 10,000.
It gives average column.
Right. This is the 10,000 records actually. 10,000 is viable, possible. Okay, so what thing we use, as you told, there, what we use, parameters, we have these many parameters in the sheet. This is ideally we have found out. It is measuring whether it is orange or grape. Two fruits is measuring. So what value is being used? It's not possible to differentiate with the two parameters having here. We need multiple parameters because grape might be green, red, or blue, or they might have.
Not great.
Lemon is always
Possible to differentiate.
So what thing will we use? Two things we want to have. So is it? Okay. Yes, sir.
Color wise also there is a difference and diameter wise also there is a difference.
Yes, so we generally have to take color. Generally, you have to take color. The green. Okay, tell me what parameters you're saying. We'll just try to have the values. What values you want to have? I guess. Color. What is color? Next.
Diameter.
No. Citrus.
Alcohol, citrus percentage.
What do we call it? Citrus fruit and citrus is there. Citrus is a.
Chemicals.
So we need to check that in which parameter they measure. I mean, in which unit they measure.
Concentration.
pH percentage.
pH value or pH value or acidity.
These are the citrus, citric acid. pH. This I am asking. It is measured in pH. Okay. So pH value.
But sir, in the data, pH value is not this.
Which status?
In previous exercise, pH values were not.
No, this is new exercise we are creating. According to what she said. Because we didn't found a ready sheet that we can use. Color and pH values. Then only two values. At the end, what do you want to identify? Whether it is orange or okay. Okay, so we need to have the data from here. pH values, we need to look for that. Citrus fruit pH values. Wine quality, citrus fruit, drawing. No, we don't have ready values. We need to create the value or we need to use the existing one. We need to have the values, color values we want in terms of temperature. Yellow and orange. Only yellow it is completely.
Red should be absent, sir.
It should be absent.
Blue should be yes.
No.
Green and blue, 50-50, sir. How much you are green and blue, sir?
We have the RGB color.
This is orange color, sir.
This is orange.
Yeah, orange.
It's changing. I think it doesn't give me the complete thing. Let me check color possibility. Binary converter means it is going the wavelength. This is yellow. This is orange. Yellow it is.
This is orange.
This is 613. So from where varying that we need to see. From here it is varying. 600 nanometer. Is right? This is orange only. So 620. So 600 to 620 nanometer. So you have to generate the numbers, random numbers from 600 to 620. pH values. You collect the real data. Okay? We don't have that mechanism, so that's why we are just finding out a way to collect the data. Okay? Can you see we are not doing machine learning, we are just collecting the data and we are just feeding that read now. That's how collection data takes time. I told you right, 80% of the time goes in preparing the data and selecting the picture that you are going to train for. 80% of the time. Machine learning will do immediately because it feeds it completely and gives the Okay, next the pH values of crude soap. Determined by pH value Beckles induced basic cells which can also low as 2 in sour lemons. And neutral. What is 1 to 6? What is 1 to 7? Acid.
Acid numbers 1 to 7.
So the scale is from 1 to 14. 7 is neither acid nor base.
That's water. 1 to 7. What is it? Acid.
1 to 7 acidic, 7 to 14 base.
So they are talking about low as 2. So that means it is near to the acid. Very much acid. Yes. We need a chart, so let's go for images.
Orange 8.6.
3.6 plus or minus 1.9. And lemon 2.34, 1.8. And color we have to change it. Color, what is the color of lemon? Color of lemon yellow. Lemon might also be green sometimes.
Dark green to lemon yellow. That is the range.
This is dark green. 540.
Yeah, this is the dark yellow color. Right numbers.
So we'll start from here. 520. 522. 575. 580. This much is enough. 580. 520. 580. Five is the range. So this data has to be randomly arranged. Right? So next time you have to cut paste all of them and you have to insert them, randomize them. This is serial data. Or else we have to tell to the function to randomize it. If you don't have here random, do that random programmatically. Okay, how about the pH values of orange?
Orange was 3.6 plus or minus.
3.6 till something range.
That varies in the range 3.4 to 3.8.
Okay.
Whereas lemon varies from the range 2.24 to 2.54.
Okay.
So there is a separating margin of 0.8 between them, between their extreme values.
Okay. So here they have some different number. 2.39. This one 4.09. 2.09 they have given for orange. Here they have 3.6. So we'll consider it from 2 to 4. 2 to 4 orange. 2 to 4 any number. 2.5.
2.8.
2.8. 2.9. 3.2. 3.6.
Almost a random. So what is the range, sir? 2.4 to
2.4 to 3.6.
2.4 to 3.6 random number, sir.
3, 3,
3.0. 3.01, sir.
3.5.
2.7, sir.
2.1.
2.95. 3.40. 3.15.
No, next for lemon. For lemon, how much? It is 2.39. It is saying 2.39 or 2 point
Plus or minus.
2.3 to
2.29. 2.29 to 2.57.
so lemon is all same it is. I mean, any lemon you cut same pH value. Okay. Same pH value, right?
So some lemon contains low pH. That is
I
not
think that is 0.17 plus or minus.
Yeah, plus or minus 0.17.
Here they are given 0.17, but it is near to that only. Plus 1.1. Lemon it is 2.34.
So 1.8 is wrong, I guess.
I think so. Because it is very much acidic.
Yes, sir. There is an error margin or safety margin, sir. They have given. That cannot be 50%.
Right. It is more acidic. It's like HCl.
So it's like 2.34 plus or minus 0.18, sir. Because that is 0.5% of the 2.34.
Yes. So we can take 3.5 till 3.5.
That there is a
1.8 there is one.
0.18, sir. 0.18 is correct. Plus or minus
1.8 is correct. Huh? This is correct. 0.1117.
0.17. I think that is correct.
Small
Because it is
variation.
almost 50% of the 2.34. Error margin, how can that be 50% of the original balance?
Okay. So what we consider
2.39 plus or minus 0.17. So
2.39.
So we need to vary between 2.2 to 2.57. 2.2 to 2.6.
So 2.39 will be the boundary and the condition.
No, sir. 2.2 to 2.57.
2.2 to 2.57.
57.
2.3.
2.25. 2.52. 2.28. 2.49. 2.31. 2.45.
And we just have few values, and we just have 8 numbers here and around 16 or 50 numbers. We need to have more numbers here. This is from 520 to 580. 570, I think. Yeah, we have just numbers. 5.33,
2.42.
okay,
2.35.
okay, Okay.
2.40,
0,
2.38,
2.38,
2.38 again. 2.41.
46.
Yes.
Now what? Whether it is lemon or orange? It is lemon. It is orange.
Can we take a problem?
Which one?
Orange. Lemon, if it is less than 2.6.
No, that will consider. That will do multiplication and division. Now we are ready with the data set. Okay. So any problem that you decide, you have to decide the key features and then decide the y value and collect the data and prepare it. Now you have prepared it. If any missing values are there, those things you have to remove it. Like this kind of a situations you have to remove it because algorithms do not accept such values. Blank values are there. And in place of this, to manually go and change them, you have to write a program to identify such values in all the columns. Then you have to write a mechanism if they found it. Like if condition I'm writing, if I found some alphabets in place of numbers. So what should I do? I should write it immediately next statement. Alright. So there will be different mechanism and we have like the previous value I can replace it with the next value or value. Like if I'm missing this value, I can replace this value or this value in the chart piece. Exactly duplicate of value. Like 2.7 itself, I'll write. Okay, most probable value is that one I consider it. Or I will write my any random number. Okay, any value I can specify there that I can write it. Or I can delete the complete row itself. Is another option I will be having. Like I don't know what to replace. So I will delete this whole 14th row itself. That is my another decision. Alright. These all methods that you are applying will be the data cleaning part of it and data preparation part. Now it is ready. So I have to save them in. Okay, I have to delete this thing firstly. Let us delete this. I don't need this sheet. So presently it is in CSV sheet. So we need to save it somewhere. Let us save it somewhere. On the desktop, I'll save this as YAML folder. I have citrus.csv and saving it in .csv file. And whenever you write a program, you have to use your read CSV and read the data. Right? And that program you have to use it firstly to acquire that data into your program. And after that, you have to divide that or split that data, test the train data. Then you have to have X and Y value ready. Test the train or data is ready. Selecting the algorithm. Okay, let's go ahead. Okay, so now I need to read the CSV. This is my first data. Okay, have you followed all the steps now? Did you follow? So what we did presently, we just collected the data. We have gathered the data. We are ready with this thing. Data preparation. Few hours of measurements later, we have gathered our training data. Now it's time for us to next step is to machine learning. That is data preparation, where we load our data into a suitable place and prepare it for use in our machine learning programs. Training. We first put all our data together and then randomize the order. We don't want the order of our data affect that what we learn. Since that it's not a part of determining whether the drink is beer or wine. In other words, we make determination of what a drink is. independent of what drink came before or after. This is a good time to do all the pertinent visualization of your data. So whatever data presently you have collected, you have to firstly visualize it. Help you to see if there are any relevant relationship between the different variables you can take advantage of. So you need to visualize the data. How do you visualize the data? With a scatter plot. Okay, so present data we wanted to plot in a scatter graph. So how do you do that? How do you design a scatter plot?
Import matrix.
We need to import what is happening. Import matplotlib dot pyplot. Okay. Next. That's it.
We have to remove the Excel sheet.
We need to have Excel sheet. Now import import pandas. Okay. Okay. Ready. Next.
We have to remove the data tables.
So
We have to select the data frame.
We have to. With open. I can also have directly read CSV.
So import CSV. Import CSV.
Where I can have this read CSV
So PD
in PD doc. But it is saying nothing is there. It is having. Okay. So we have data equal to. So next path we need to give it. So presently I am not having that sheet here. I wanted to bring that sheet. It is in ML folder. I will paste it here. I'll open them. And I'll paste it here. And now I have my citrus dot CSV. Citrus dot CSV exists. Okay. Further. Print data. Okay. Data only. Shall we do this?
Yes.
The file.
Only 5 hours will be there. Activity. We have a problem here. Unknown. Okay, ready. Next. How about last rows I want to take? Okay. So totally I think we have 29 numbers. So we have all these things being listed out. Okay.
software element is a labeled data.
Complete level data. Okay, this much we have it. We'll keep it in a place. Next. Next, what need to do?
That preparation is we need to feed with the YAML.
Feed the data, sir. Data algorithm.
Algorithm selections.
No, presently is the data is ready.
Train the data, sir.
Model center model.
Is the data is ready?
First, we get a model and training the data.
Okay.
Data is, I think we need to create a data frame.
Data we have, but do we also use the headers here?
Headers we should not use. First row we need to skip.
Yes. So that we need to do. And only we need to consider first two columns. First two columns we need to use, and we should not use the last column. And we should specify that. Okay. Next we have choosing a model. Let us first clear the data. Let us prepare the data. That's why we are told here. If you are a measurement data, we have gathered our training data. Now it's time for the next step is step of machine learning, data preparation, where we load our data into a suitable place and prepare it to use in your machine learning training. We took the data from here and we loaded them into X and Y, and then we reshaped them. Presently, we don't need to have reshaping here, and here we are just split them, and we have given X and Y values. So we need to have X and Y values. So what are your X values and what are your Y values? You're not doing online also?
No,
Exams are over?
no, sir, at 25 final exams, these many days like and it's for that.
Understand?
Many projects.
Yeah. Continuously there is exams.
Yes.
Practical exam and all.
Yes.
Attend it after that. Are you also watching the videos that we are uploading?
Recorded session.
You're listening? Then it's okay. Okay.
So this week also I will not.
Okay, not only here. You join online and watch the videos. After that, we'll see. Okay. Okay. Yeah. So here we are trying to create two things, X and Y. We need to have what are your X and what are your Y's. We need to prepare. Yeah. Both the values, and we need to shape them. How do we create? X is color.
Yes.
Y is pH value.
Yes.
Okay. You have executed this thing, right? Yesterday. So you have taken only one thing here. I mean, this one thing you have taken it as the X value, and another value you have taken it as Y. Okay. But now we have two values.
So we need to first one, sir. XO and L. We need to define those values like this. XO for orange, YO for orange, XL for lemon.
So firstly, you wanted to visualize them. That's the next task that I have. You wanted to plot something with the help of this data. So how can we plot them? Why is not giving me?
Key value, give key value.
Key value means
First name.
First row is of alphabetical.
Because it is distance from
Okay. So what is the name I have there?
colors.
Color. So I have my serial numbers also printing. I don't need them. Further. Okay, there is index numbers. They are not involved. Next,
PH values.
I have PH values. H underscore values. PH underscore value you don't have. Value we have, not values. All of them getting printed one by one. Okay, next. We are able to access them. Next, I want to visualize.
You can go for a line graph.
Line graph or scatter plot? Scatter plot. Go scatter plot. Okay, how can I go? Plot.
PD dot cross.
PD dot. We are plotting.
Just plot. PD dot plot.
Plot.
Data of zero. Data of color.
PH value.
Next.
Plot. Plot. Scatter. Data.
Data.
Yes.
Okay.
PNP. PNP dot show.
Pandas has no attribute called plot.
PD dot PNP.
The period is a period. You are taking period is a-
Press down all those points like this. Scatter missing one required parameter argument called y. What parameter you can give to scatter plot? Given x array like, y array like. What you can give?
Data of colors.
X value
Colors.
where are x equal to
Data
it of
colors.
okay.
Are equal to PH values.
But it's also giving me the normal plot. Okay. Now presently you have Excel sheet of this data. Okay. So this data is very small data. Group of dots. Okay, two groups, two different groups you have. You can see on this one.
Yes, that is so.
Okay, so that way you can have it. How can I give a different color to this one? Recently we have done. Color, what colors?
Labels select.
Where?
So comma color.
Apply for data is
Comma colors.
Comma, color.
Colors. Colors.
Color equal to we have. Colors we not actually. It's color we have. Next. Double quotes are red.
Yes.
So red, orange, yellow,
Orange. Yeah, double.
comma colors.
Comma, color.
सर ये इसमें कलर से पहले कलर से हम पेज वैल्यू वेरी कर देते हैं
That's what
Here is, sir, you mention X at
X only here. X equal to yellow.
red.
सर कलर इक्वल टू रेड एंड ग्रीन
Where should I mention? Shall I remove this one?
Sir,
After X only.
sir,
Color.
color equal to pH value color equals to
No, here I should write or where should I write? Here. Already I have a parameter. Here I should write blue.
सर कलर इक्वल टू लास्ट कलर इक्वल टू कलर ग्रीन ब्लू रेड एंड ग्रीन
How should I write? Comma, like this.
कलर इक्वल टू ग्रीन
In double quote.
Orange and yellow.
How can it take? Because you are saying
pH value equals to
pH value is column name. Here I should write a equal. pH value equal to green. But not take it.
सर इनसाइड पैरेंथेसिस
Insert parenthesis. With this,
रेड एंड ग्रीन
no, it is not taking. This blank. C argument has two elements, which is inconsistent with X and Y with the width of size. Now, what it has, what parameters it has? It has C equal to array like list of colors.
Colors.
List of colors. Argument has two elements, which is inconsistent with X and Y. Yes, how do you do that? Okay, no problem. That is really the advanced thing. So how do you create a line with this one? So you have the two data points. Here you have one data group. Here you have one data group. So minimally you have to draw the line like this only, right? So what are things you want? You want a slope, okay? Or in other way you can write it. So you need a slope. You need the intercept. So presently the intercept will not be on the y; it will be from the x side. Okay. So this one I am saying. CRP. But this is sorted out on this other side, and you are giving these things from here. Okay. And M is the one which is going to tilt. So it may draw like this, or it may draw like this. Okay. So these are your M's. The number of values that it can calculate every time. So this yum will change and it will calculate that. It will be done by machine learning. So we don't have to worry. We just have to do the data that we have. Okay, we just have to tell the algorithm to take this data and do it. Algorithm will take care of it, not the system. Okay, now we understand that there are two groups. Before this, we didn't know that HLC is having two groups. All right. Okay. Further, data preparation is done. Now we are ready. Further, choosing a model. What model you want to choose? The next step in our workflow is choosing a model. There are many models that researchers and data scientists have created over years. Some are very well suited for image data, other for sequences like text and music. Some are for numerical data. Okay, some are for basic, text-based data. In our case, since we have only two features, color and alcohol, we can use a small linear model, which is a fairly simple one that should get our job done. That we can go ahead. So linear model we can use it. So where is a linear model? Yeah. So where is a linear model? How do I take the linear model and start using that? And before that, shall I prepare the data? Have you seen the linear regression program? Okay, have you followed these steps? Just you have to check it. So we installed all of them. Stats model we are not installed. Import packages and classes that you need, provide data to work with, eventually do appropriate transformations, create a regression model and feed it with the existing data, check result and apply the model prediction. So import NumPy we have done, and we have not done this thing. Okay, so let us import that. What do you need to import? Where is the linear regression?
From sklearn, linear regression.
From sklearn.
From sklearn, not linear model. From sklearn dot linear regression, linear underscore model, linear underscore model, import linear regression.
Import linear regression. Okay, that is done. But it is giving me the yellow line. Let us.
So that's yellow with me also, but this code is running.
Okay. Okay, let us take a. No, model is not there, it is saying. So Python 3.11.2 has to run.
Again, there are, I think, SQL version. There are many versions of SQL and they are different versions of Python. SQL 0.2 needs 2.7 and 3.7 Python. SQL 1.2 needs Python 3.7 or newer.
Python 3.7. Below Python, what is the maximum value?
It's not like this. Each range of SQL needs a different range of Python versions.
Latest version is needs.
SQL, if we are installing 1.1 of SQL, then we need a 3.8 or newer of Python. So first we need to check what version of SQL we are installing, and according to that we need to change Python version.
3.9 version.
So can we check the version of the SQL we have installed?
Yeah, it is 0.0. It is showing presently.
0.0.
Post 5.
Or what version of Python is running sir currently? According to that, we can install a SQL version.
Three point 9.17.
3.9.17. Sir, better to go for SQL 1.1, sir.
SQL 1.1.
Yeah, SQL 1.1 needs 3.8 or newer.
It is saying newer one only. Updatable any of them are there. We have to specify here actually. Nextcaler is having the latest version only. Latest one only.
Are you
I'm
making use of
taking it to, yeah, I'm just taking it to the Jupyter app. Let's see. So it is not taking that. It is taking the version. Let us continue here. Yeah, it is taking other things. Let's go ahead. Now, further we need to create a model, and further we need to have the data x, y ready. Yeah, I'm just waiting. So we have the x value as matrix. So we have two things. We need to specify two things here. Okay, it's 6:30 now. There will be assignment for you. Get the one Excel sheet of data of this kind of features, and we'll create a model for your Excel sheet. The next class. Okay, so that we can understand how can we create our own. Whenever I want it, I will I'll create my model, and that my machine learning start my task. Alright, that's how we regularly write a program. Let us write a machine learning program like that. Then only we will understand what those algorithms will be doing with us. That's right? You get me the program till the data display. Whatever data you will be taking tomorrow, that data you get it along with the program. That program must display your data in the plot. Okay? And you push that and send it to the before the class.